Hi everyone, this is Mark Schwartz from Astronics, coming to you from Apex 2019 in California. Today I'm going to tell you a little bit about our new IFE system called Edge. Edge is based on a new architecture called distributed computing. What's the difference with today's architecture? So a typical architecture of a system today is comprised of a head-end server. The head-end server contains high-end CPUs as well as all the disk drive space. The problem with it is that they run very hot. It's required that they get installed in the eBay through a tray, and they also require active cooling or fans. So because they run hot and require a fan, they're typically a single point of failure on an aircraft. If one of these goes down, the aircraft will be dark and there'll be no in-flight entertainment or connectivity. What we've done is we've rethought the architecture. We've taken the CPU and the hard drive space out of the head-end server and we've put it into the WAPs. So each WAP has its own CPU and its own fraction of the hard drive space. So again, that's distributed computing. Now we have more than one computer essentially driving the system. There's no more single point of failure. So for example, if the center WAP were to go down with a smart WAP like this, the other WAPs would take over and heal the system automatically, and there would be no disruption to the passengers. No more single point of failure. In the new architecture, we replaced the head-end server with just a simple interface box. We call it an AIO. Basically, it's just a connector interface. In this case, we have our content loader, which downloads movies through the AIO box to the WAPs. And then these connectors will be connected to the satellite system in the case that you would have connectivity. The other things that are unique about the system is because since the processing is being done locally at each WAP, there's less of a requirement on the cables. Remember, with a head-end server, you got computations and all the storage is on the head-end server, which means the cables have to be very fast because they're feeding the WAPs information, whereas these are essentially generating the streaming information themselves. The other thing that's really good about this system is it's completely modular and scalable. Think about a small aircraft, you would only need one of these. A narrow body, low density aircraft, you'd need two, etc. The problem with a high-end server is this would be huge overkill for a smaller aircraft. So in other words, this would be like putting a Ferrari engine in a Yugo, for example. You wouldn't want to pay for this expensive, powerful device because it'd be too much for that particular plane. This system will scale all the way up to long-haul, dual-aisle aircraft as well. Thanks for listening.